Okay, hi everyone. I would like to explain my PhD topic to you today. And my study deals with order picking optimization in the warehouse of a South African retailer. So what is order picking? That's the first question that I'm going to ask myself if I hear about that topic. Order picking is, if you look at a warehouse, you get a lot of bulk stock from a supplier. So for example, you would get 100 t-shirts. And then you would have to turn this into customer orders or store orders. Say, for example, store A needs 5 t-shirts, store B needs 7 t-shirts, and so on. So what happens in the warehouse now is there is a person that we call the picker who's walking around and collecting the different items that the store needs to sell to other customers. And then what happens now is that I have a specific layout which is called the picking line, and in that retailer layout that I'm looking at, we have a conveyor belt and we have the different products around that conveyor belt, and the picker walks around and picks all the items for the orders. Now, how can I optimize this process? I would like to minimize the walking distance so the picker has to walk. And there are different ideas on how I can do it. And one of the ideas is called order batching. And what order batching does is you do not only pick one order at a time, but you pick 2 orders at a time. Now, if I want to introduce this to my systems, there are 2 questions that arise. The first question is, how can I measure the distance between 2 orders? And the second question is, how do I now combine these different orders? And yeah, to answer the first question, I must obviously take the specific layout into consideration and then try to measure how far the orders are apart from each other. And to answer the second question is also fairly tricky, because if you look at one picking line, it usually services up to 1,300 orders. And if I just want to combine the best 2, I would have, by having 1,300 orders, almost 1 million different possible combinations that I can check. Obviously, this would take forever, even if I use a nice a computer system. So I'm not going for an optimal solution, but I'm trying to find a solution that is close to optimal. And therefore, I use different heuristics and different meta-heuristics. So it's just a higher level approach of algorithm that gets to a solution quickly, not to the best solution, but to a very good solution. And now I'm actually able to solve the problem in 5 seconds. So the conclusion of the research is that I try to combine the measurement on just giving a rating to the different orders and the algorithm to, in the end, say, okay, I can use this measurement and I can use this algorithm, and hereby I can batch my orders together and minimize the walking distance, thereby save time and eventually save money. I hope everyone understood now what my PhD is about. It's not too easy to explain, but thank you very much.